All right, let's talk about one of the biggest headaches in Kubernetes, DNS. You know, as your clusters get more and more dynamic, how do you stop your DNS management from becoming this slow, manual, and, frankly, dangerous bottleneck? Well, that's exactly where a tool called ExternalDNS comes into the picture. And today, we're going to break down precisely how it saves the day.
To really get why this is such a big deal, you have to look at the clash of two different worlds. On one side, you've got the old way of doing things, traditional infrastructure. Everything's static, predictable. A DNS change means filing a ticket and waiting. And waiting. Then, on the other side, you've got Kubernetes. It's fast, it's dynamic. Services and their IPs pop into existence and disappear in minutes. These two worlds, they just don't play well together at all.
So, this leads to the big question, right? Your applications are deploying all the time. Your infrastructure is scaling up and down automatically. So why is your public DNS still getting updated by hand like it's 2005? This gap isn't just inefficient, it's a major operational risk.
Let's dive into that risk. We call it the manual DNS bottleneck. But it's not just about slowing your teams down. It introduces a really specific and pretty nasty security problem known as dangling DNS.
Okay, so what is dangling DNS? Let me paint you a picture. Imagine you spin down a service in Kubernetes. Poof, it's gone. The cloud provider immediately snatches that IP address back and throws it into a public pool for someone else to use. Now, if you forgot to delete the DNS record that was pointing to that old IP, well, someone else can get assigned that exact same IP address. And just like that, your domain, api.yourcompany.com, is now pointing to their server. That's called subdomain hijacking, and trust me, it's a security nightmare. So that's the scary part. How do we fix this? This is where external DNS makes its grand entrance. The absolute best way to think about it is as a bridge. It creates this automated direct connection between everything happening inside your Kubernetes cluster and the configuration at your DNS provider, whether that's AWS Route 53, Google Cloud DNS, or Cloudflare.
Now here's a super important point. External DNS is not a DNS server itself. It's not like core DNS inside your cluster actually answering queries. Think of it more like a configuration management tool. It's a tireless little robot that just watches your cluster and then tells your real DNS provider what records it needs to create, update, or most importantly, delete.
Okay, so how does this automation magic actually work? Let's pop the hood for a second. It's all built around a continuous process, a really elegant one, called the reconciliation loop. This loop just runs over and over all day long. It's got 3 simple steps. First, it observes. It looks at the Kubernetes API and figures out, based on all the services and ingresses running right now, what DNS records should exist. That's your desired state. Second, it retrieves. It goes out to your DNS provider and asks, okay, what records do we actually have right now? That's the current state. And finally, it executes. It compares those 2 lists, figures out the difference, and makes whatever API calls are needed to make the current state match the desired state. Simple, powerful, and it never stops.
So that's how the tool works. But how do you, as a developer, control it? How do you tell it what to do? And this is the beautiful part. You don't talk to it directly at all. Instead, you start treating your DNS just like you treat the rest of your infrastructure, as code.
The way you do this is just brilliantly simple. You use annotations, which are basically just special labels, right inside your Kubernetes YAML files. The most important one, of course, is the hostname annotation. That's where you say, I want this service to be available at api.example.com. You can also control other stuff like the TTL for caching, or even override the target IP. And just like that, your public DNS configuration now lives right alongside your application's code. How cool is that?
Okay, this all sounds amazing for a simple setup, but what happens when you go big time? You know, when you're running this in production with multiple teams, multiple clusters, all potentially touching the same DNS zones. How do you run this safely? Let's talk about mastering day 2 operations. And that brings us to what's known as the ownership problem. Imagine you have 2 different Kubernetes clusters, one for dev and one for prod, and they're both trying to manage records in example.com. How does the dev cluster's external DNS know not to accidentally delete a production record? If they don't know who owns what, they'll just fight each other all day long, creating and deleting each other's records. It would be total chaos. The solution here is really clever. It's called the TXT registry. Here's how it works. Every time external DNS creates a record, like an A record, it also creates a tiny little companion TXT record right next to it. Inside that TXT record, it puts a unique owner ID that you define.
It's literally like putting a digital name tag on the record that says, hey, this one's mine. I'm the prod cluster. Now, it will only ever touch records that have its specific name tag, safely ignoring everything else. Problem solved. Of course, none of this matters if it's not secure. I mean, we are giving a tool automated control over our public DNS. This has to be locked down tight. And the number one goal, the absolute top priority, is to get rid of static, long-lived API keys and secrets. Those things are just a ticking time bomb waiting to leak. So for AWS, the gold standard, the best practice, is using something called IAM roles for service accounts, or IRSA. This is a fancy way of saying you can link an AWS role directly to a Kubernetes service account. So instead of a permanent key, the pod just uses its identity to ask AWS for temporary auto-rotating credentials. It's absolutely the most secure way to do it. Over on the Google Cloud side, they have a very similar, equally secure system called workload identity. It's the same idea, just a different name. You're binding a Kubernetes identity to a cloud identity, allowing the pod to authenticate securely to the CloudDNS API without ever needing a static key file. And you guessed it, Azure completes the trifecta with Azure Workload Identity. Again, same core concept, you're federating your cluster's identity with Azure AD. This lets you give the external DNS pod a very specific, granular role, like DNS zone contributor, and only on the single zone it needs to manage. Now, for providers like Cloudflare, you have to be a little more careful. Whatever you do not use your global API key. I'm serious. That's like giving away the root password to your entire account. Instead, you create what's called a scoped API token. This lets you create a key that only has permission to edit DNS records and only for one specific zone. It dramatically shrinks the blast radius if that key were ever compromised. Okay, one last production tip. Let's talk about safety policies. External DNS has two main modes. The default is sync. This is the full power mode. It creates, updates, and crucially, it deletes records. This is the mode that prevents dangling DNS. But it carries a risk. A misconfiguration could potentially delete valid records. So for a safer start, you can use upsert only. This mode will create and update records, but it will never delete anything. It's a great, safe way to get started, but just be aware that you'll end up with stale, orphaned records over time that you'll need to clean up yourself. So when you put this all together, what's the big takeaway? I think this quote really nails it. External DNS enables a truly declarative infrastructure. It fundamentally changes how you operate. DNS is no longer some separate manual process involving tickets. The public DNS record for your service becomes just another piece of code, versioned in Git and deployed right alongside your application. It's a total game changer. And that really just leaves one final question for you to think about. As you embrace the incredible speed and automation of Kubernetes, is your DNS strategy actually keeping up? Or is it still the slow, manual bottleneck that's holding you back? Something to think about. Thanks for watching.